Envision a titanic ensemble made out of a limitless exhibit of stars, planets, and moons, all fitting as a solitary substance. Anyway, there exists one specific segment of this great orchestra that has jumbled cosmologists for a significant stretch. Exoplanets. These are conventional planets found external our own nearby planet group, concealed deep inside the Milky Way. It might flabbergast you to understand that among the huge number of galactic items, there exist exoplanets that look similar to Earth. This discovery makes way for an astounding turn, similar to something out of an undeniably exhilarating sci-fi experience. Researchers utilizing the James Webb Space Telescope caught something uncommon from Proxima b, an irregularity so peculiar it resounded across scholarly conversations and social media, being named a potential technosignature. It was an electromagnetic discharge so complicated and so significantly organized that it raised the chance of a high-level civilization existing in the district. Humankind's collective heartbeat seemed to freeze at the pinnacle of this revelation, one that could perpetually change our impression of existence. Could this transmission be the definitive proof that we are not alone in the universe? But just as quickly as it appeared, the transmission evaporated without reiteration, abandoning a staggering silence as well as a perplexing snare of unanswered questions and fermenting hypotheses. Was this only a transient, inestimable abnormality, an arbitrary arrangement of divine events, or something undeniably more purposeful, a coded message or even an indication of a disrupting inestimable presence? The solitary mission cast a sad remnant of mystery over Proxima b, igniting extraordinary discussions and hypotheses. Was this a temporary peculiarity or part of a boundless story? Definitely more unpredictable than we can imagine. However, wait, our huge story is unfinished. The ink on this account hasn't dried, and new sections are still being written. This time, it isn't just NASA specialists but Harvard specialists who are leading a change in the way we approach the quest for extraterrestrial life. Their focus goes beyond analyzing the oddities and transmissions we've noticed so far. They are upgrading the game by transforming the James Webb Space Telescope into a tremendous night vision apparatus, explicitly designed to look for artificial light sources in both dark and illuminated regions of distant worlds. We're considering captivating potential outcomes, such as identifying Earth-like metropolitan habitats shining in the dark like brilliant cities, enlightening the vast galactic seas. As we continue to uncover the secrets of the universe, the journey for extraterrestrial life takes on a completely new aspect. Beyond Proxima b's prompt interest, our grand search digs further into the immense and confounding domains of space. This pursuit is driven by innovative advancements as well as by an unquenchable curiosity in our place in the universe. Continuous breakthroughs in cosmology and space exploration have led to the identification of various exoplanets that might potentially harbor life. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories have significantly improved our ability to identify and study these distant worlds. One especially intriguing area of research is the search for biosignatures, signs of life. Biosignatures could include atmospheric gases, such as methane or carbon dioxide, which under specific conditions could indicate biological processes. The JWST's abilities extend beyond simple detection. Its advanced instruments allow for precise measurements of the atmospheric composition of exoplanets. By studying starlight that filters through an exoplanet's atmosphere, researchers can identify chemical markers associated with life. For instance, the presence of water vapor alongside molecules like oxygen or ozone could indicate conditions conducive to life. Another promising avenue of exploration involves examining the conditions of these distant worlds. In addition to biosignatures, the possibility of technosignatures, hints of advanced civilizations detectable through artificial structures or technology, has gained some momentum. These could appear as engineered megastructures, like Dyson spheres designed to capture the energy of stars, or as unusual radio emissions. As we refine our observational techniques, the search for technosignatures could uncover extraterrestrial intelligence beyond technological advancements. Global collaborations are crucial for the quest for extraterrestrial life. Partnerships between space agencies, research institutions, and private ventures enhance our ability to explore the universe. Missions to Mars and other celestial bodies, for example, are international efforts pooling resources and expertise to achieve common goals. Public engagement and education play a vital role in this endeavor, as the excitement surrounding space exploration inspires future generations of researchers and scientists. Outreach programs and educational initiatives foster interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies further enhances our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to detect and analyze distant exoplanets. Cutting-edge space telescopes like the Extremely Large Telescope (ELT) and the Habitable Exoplanet Observatory (HAB-X) are set to provide even more detailed observations, offering further insights into the potential habitability of distant worlds. With every discovery, new questions and areas for investigation emerge. The quest for extraterrestrial life isn't just about finding alien civilizations. It's about understanding the origins and potential diversity of life across the universe. It challenges our perspective and broadens our understanding of being. All in all, the exploration of exoplanets and the search for extraterrestrial life are dynamic, evolving fields. With each advancement, we move closer to answering some of humanity's most profound questions. As we continue to explore the universe, the possibilities for discovering new forms of life and understanding our place in the cosmos remain endless and tantalizingly close. It's possible that Proxima b could be our planet's celestial twin, located just 4.2 light-years away. It stands as one of the most intriguing astronomical mysteries. The James Webb Space Telescope is revolutionizing our search for extraterrestrial life, enhancing our understanding of these infinite conundrums. Imagine a moment when your thoughts cross the vast expanse of our galaxy, the Milky Way, which contains more than 1,000,000,000 exoplanets. That's a 1 followed by 15 zeros. To put this into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon, but we would have enough to create another landmark on Earth. The Grand Canyon 2.0, stretching across an enormous distance. What's even more shocking is that roughly 20% of these celestial bodies have been identified as Earth-like in terms of their geological and environmental features. This means there's a 1 in 5 chance that we could find a twin to our planet. The story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our own moon, locked in gravitational dance with their parent planets. If you're hoping to find another body in space capable of supporting life, or one that might potentially do so, the universe presents an endless array of possibilities. Now that we've revealed the sheer extent of this vast realm, it's time to introduce the real genius, the James Webb Space Telescope. This exceptional instrument, with its remarkable focal length and flexible lenses, outperforms even the most advanced optical technologies. We're not talking about just any lens. This telescope features a 6.5-meter primary mirror, 2.7 times larger than Hubble's. Imagine the clarity it provides, even when surveying the faintest glimmers of distant stars, billions of light-years away, and analyzing the details of the planets orbiting them. What makes the James Webb Space Telescope revolutionary isn't just its observational power. It also incorporates cutting-edge technologies such as high-level sensors and spectrographs. These instruments accomplish something beyond notice. They dissect and decipher the exceptional light marks transmitted or reflected by divine objects, uncovering their climatic circumstances, structure, thickness, and, surprisingly, mass. Like a space investigator, it can decide if a planet has water, natural mixtures, or even oxygen. The James Webb Space Telescope is equipped for responding to these inquiries, hoisting it from a simple observational instrument to a logical virtuoso. It's not just an improvement over Hubble. It's a quantum jump forward. Assuming that Hubble's disclosures left you in stunningness, get ready for a genuine blast of heavenly disclosures as we broaden our view across the perplexing landscape of the universe. One specific star in the enormous expanse demands our attention: Proxima b. Since its revelation in 2016, this confounding planet has enraptured stargazers and astrobiologists alike, earning a spot at the center of attention because of its capability to respond to significant inquiries. Why all the attention? First, Proxima b is surprisingly close to our infinite neighborhood, just 4.2 light-years away. To put this into perspective, if you could surpass the infinite speed limit and travel at the speed of light, you'd reach it in just a little more than 4 years, about the same amount of time it takes for a TV program to rerun its episodes. Anyway, let's dive deeper into why this proximity is so huge. In a universe that spans more than 93 billion light-years, finding a planet so close and so ready for scientific investigation is like finding a diamond in a pile the size of Mount Everest. A diamond that may hold the key to secrets about life itself in the grand woven fabric of the universe. Proxima b is a multi-layered pearl, offering us precious hints that could reshape how we might interpret tenability and life beyond Earth. It's not just the proximity of Proxima b to Earth that excites researchers, but also the tempting signs suggesting that this planet could be Earth 2.0. Proxima b sits comfortably within the habitable zone of its parent star, where conditions are neither too hot nor too cold, just right for liquid water to exist. Imagine waterfalls, flowing rivers, vast lakes, and potentially even oceans as deep and mysterious as the Mariana Trench. Yet, before we start dreaming of venturing out to Proxima b, we need to consider a few quirks. For instance, a single day on this fascinating exoplanet lasts a shocking 11 Earth days. Picture dusks that stretch over extended periods, creating captivating views that photographers would envy. While this might sound idyllic, it also raises several significant challenges for its environment and livability. How might human biorhythms adjust to the cycles of light and dark on Proxima b? Would we need to eat more often, maybe 3 or 4 times a day? Would we sleep the same way we do here on Earth? The fundamental aspects of life as we know it would be eerily similar, yet strikingly unusual. Nature seems to have given us a puzzle wrapped in a mystery, forcing us to rethink what makes a planet truly habitable. You might wonder, how can we gather reliable and accurate data about a world we've never visited? That's where the James Webb Space Telescope comes in. It's not just a telescope, it's a refined research lab in the vacuum of space. Thanks to its cutting-edge technology, researchers can not only observe distant planets but also study them with a variety of scientific instruments. With advanced spectrographs, the JWST can examine the light emitted or reflected by these distant planets. Each component in a planet's atmosphere absorbs or emits light at a specific frequency. By shining light on these patterns, researchers can perform a remote biopsy of these celestial bodies, measuring air pressure, density, and even identifying compounds necessary for life, such as water, organic carbon, and oxygen. This isn't cosmology, it's space forensics. Rather than passively waiting for clues, we actively seek them by examining the atoms and molecules that make up these distant worlds. The JWST isn't just an eye in the sky. It's a highly specialized lab and cosmic detective rolled into one. It enables us to transform our hypotheses and theories into confirmed scientific discoveries, changing our understanding of what might exist beyond our pale blue dot. Right when you thought you had uncovered the deepest layers of this vast cosmic tapestry, the journey is just beginning. As we stand on the edge of momentous discoveries, the James Webb Space Telescope represents a hopeful beacon and advancement. Its high-level instruments are designed to probe the most intricate details of distant worlds, uncovering aspects of the universe previously beyond our reach. The JWST's ability to analyze exoplanet atmospheres allows us to extend our investigation to the farthest corners of space, providing insights not into whether these planets could support life, but how life could appear under different conditions. One especially exciting part of this research is the potential to identify biosignatures in exoplanet atmospheres. Such signatures, like specific atmospheric gases or chemical compositions, could indicate biological processes. For example, detecting a mix of gases like methane and oxygen could suggest biological activity, as these substances often result from life processes on Earth. The JWST's advanced spectrographs can detect these subtle signatures, offering a new window into the possibility of life beyond our solar system. Moreover, the search for exoplanets has led to the discovery of various planetary systems, each with its own unique characteristics. Some exoplanets have been found in binary star systems, where 2 stars orbit each other, creating complex gravitational conditions. Others orbit red dwarf stars, cooler and less luminous than our Sun, but still potentially capable of supporting habitable zones. The discovery of such remarkable exoplanetary systems opens up new possibilities for where life could exist, even under conditions we wouldn't typically associate with habitability. For example, planets orbiting red dwarfs, which are far more common than Sun-like stars, might offer stable conditions capable of supporting life despite the star's lower luminosity and increased variability. This growing diversity in exoplanetary systems, driven by the search for life, shows that habitability may not be limited to the familiar conditions of our solar system. One of the most thrilling aspects of this research is the potential to uncover radically different forms of life that might not resemble life as we know it on Earth. Traditional models of life often center around the need for water, carbon, and oxygen, but new discoveries could challenge these assumptions. The search for biosignatures, while focused on familiar life-supporting conditions, is increasingly open to the possibility that life could thrive in completely unexpected environments, whether in the atmospheres of gas giants, under the ice of distant moons, or in more extreme conditions that we wouldn't normally consider conducive to life. Additionally, the technological advancements available to us are enhancing our ability to detect and interpret even the smallest hints of life or advanced technology in distant worlds. Instruments like the JWST can help us identify the chemical fingerprints of life, whether through gases produced by biological processes or artificial pollutants that might indicate the presence of intelligent life. By observing and analyzing the atmospheres of exoplanets in detail, we can assess whether they show signs of biological activity or advanced civilizations, thus broadening our definition of what makes a world habitable. This heightened sensitivity to life and its markers is not just a scientific pursuit, it's a philosophical one as well. The implications of finding life elsewhere in the universe are profound. It would challenge the uniqueness of Earth and redefine humanity's place in the cosmos. Finding life, or evidence of an advanced civilization, wouldn't just answer long-established questions about our own origins, but could also suggest that life, in some form, is a common and widespread phenomenon flourishing across vast stretches of existence. Equally exciting is the broader cultural impact of such discoveries. The possibility that we could one day contact or find evidence of intelligent life beyond Earth sparks the imagination and ushers in a new era of exploration. This drives funding and research, attracts a new generation of scientists, and fosters international collaboration as we strive toward a shared cosmic goal. The questions we raise today about life, our place in the universe, and the nature of intelligent civilizations are the very questions that will shape the course of future space exploration and technological development. As we continue to expand our exploration of space, both through manned and robotic missions, we must also prepare for the new challenges that will arise. As technology continues to evolve, so too will the methods we use to search for life. We must develop even more powerful and precise tools to detect life in ways we can't yet fully imagine. The journey of discovery is ongoing, and with each new technological leap, we uncover further layers of cosmic knowledge. Looking ahead, the search for extraterrestrial life won't be about finding life forms that resemble us, or even determining whether life exists on other planets. It will be about exploring the rich variety of possibilities that the universe holds. As we push the boundaries of space exploration and technological advancement, we're not just observing the universe, we're rethinking our place within it. And in doing so, we may soon find that life in the universe is far more plentiful and diverse than we ever imagined, prompting us to rethink everything we know about the origins of life itself.